My name is Justin De Los Reyes, and I am one of the sales engineers here at ETAP. Today, I have the privilege of presenting to you ETAP's 12.5 offline webinar. In this particular offline section, we are going to showcase some of ETAP's newest additions and enhancements that we've made. One of the new additions is the Dynamic Parameter Estimation and Tuning module, also known as Deepeet. We have also added the GAUSS short circuit standard to our short circuit modules. Some of the enhancements that we will be talking about today have to do with our scenario wizard and our library merge process. With the addition of these modules, time-saving capabilities, and the additions we have made to our real-time platform, we feel that we continue to justify why ETAP is the most comprehensive enterprise solution in the market. Now that the topics have been introduced, let's begin by talking about dynamic parameter estimation and tuning. We know that knowledge of a rotating machine and its associated control system dynamic parameters is essential to any power system transient stability simulation study. These parameters include machine impedances and time constants, inertial and dampening coefficients, prime mover and governor parameters, excitation systems and AVR parameters, power system stabilizer parameters, load characteristics, etc., etc. Accuracy in hundreds of these parameters directly affect the credibility of the simulation results. In order to verify and validate the simulation studies, it is commonplace to compare simulation results against field test measurements, such as a generator load acceptance and rejection test. However, expertise is required to understand the effect of each parameter, as a simulation model is typically manually tuned to provide similar responses as the ones observed in the field test or recordings. The task of adjusting each variable via the trial and error approach simply is too tedious and time-consuming. Deepeet adds an intelligent automated layer of time-saving capabilities. Combined with ETAP user-defined dynamic modules, Deepeet automatically adjusts appropriate parameters so simulation responses match actual field measurements accurately in a matter of minutes rather than weeks. Not only can ETAP's dynamic parameter estimation and tuning modules save you time and money, Deepeet is especially useful for power plant model validation, as mandated by the North American Electric Reliability Corporation, also known as NERC. The NERC standards that ETAP helps you comply with through the utilization of ETAP's Dynamic Parameter Estimation and Tuning module are MOD 026 and MOD 027. MOD 026 specifies that the excitation system model and the model parameters used in dynamic simulation accurately represent generator excitation system behavior. MOD 027 specifies that the turbine and the load control or active power control model and the model parameters used in dynamic simulations accurately represent generator unit real power response to system frequency variations. Now let's begin by opening up ETAP 12.5. Next, we will open up an existing example file. In this case, we will be opening up example ANSI. As you can see, you can open up the UDM file through the generator editor or through the system's toolbar. In this instance, we will be opening it up through the generator editor. As you can tell, Deepeet can be utilized to model different dynamic components within a generator, such as the exciter, governor, and power system stabilizer. Today, we will be using Deepeet to model the exciter. I've selected an example that I've already pre-built and now am opening up the UDM. Once the UDM has opened up, you can see that the file that I have previously created for you is now open. As I move to the Deepeet module, you will see that different icons will now be made available to you in the top left corner. You can also see that this transfer function created in the middle of the screen was created using the control blocks located on the left. Since we no longer need them, I will minimize them and showcase the entire transfer function. If you look on the bottom right, under the model parameters, you'll see that specific variables were chosen to be tuned by Deepeet. If you simply click on one of the blocks, it will showcase where it is located and the information associated with those control blocks. Now let's go take a look at the study case of the Deepeet module. You will notice that in the study case, the parameter estimation list contains the variables located in the model parameters section on the bottom right hand corner. Now let's go and define the inputs of the voltage terminal. I'm going to select the inputs now. Once I have defined what the inputs would be, I also have the option of plotting that specific set of input information, as you can see here as for the voltage terminal. Now I will do likewise and define the exciter field voltage and also plot its input. Now you may notice in the parameter estimation list that specific variables are fixed. The reason these variables are fixed is because we know that these variables and the constants associated with them are accurate, and we no longer want the program to consider those variables. Hence why we fix kf and ka. Now if we take a look at the simulation parameters, these are the parameters in which Deepeet will conduct its studies. Now that everything has been defined, let's click OK. Now the next step that we need to take is to compile the transfer function. Once the compilation has finished, we will then run Deepeet. In order to provide an output report name, I am going to generally call this one test 1. As you run Deepeet, you can visually attest to the results provided by its multi-objective stochastic optimization method. You can also see the measured data as a comparison to the calculated data from the field. Also on this graph, you can see the deviation on each point correlating to the points on this particular graph. ETAP provides you with the option to dynamically zoom into the plots to better see the deviation as Deepeet tunes your system. You also have the option of zooming out from that zoom in. Likewise goes for the graph on the right. Here you can see that during this iteration, the deviation is between 0.1 and 0.05. As we run our way through these iterations, if there happens to be a point that you're satisfied with, you can easily click the stop icon located at the top. As you can see, of the 100 iterations that possibly run, at 97 I selected that I am satisfied with my results. Now that I have visually verified that my results are correct, I am now going to take a further look at my reports. The reports can be found by clicking on this icon. There, Deepeet will produce an Excel spreadsheet that will show you the model parameter results as far as what your initial results were and what the estimated results are based off the tuning, and also take a look at the plot points generated in Excel format, such as your measured exciter field voltage, your calculated exciter field voltage, and the deviation. Now let's take a look at Deepeet Analyzer. Although we only ran one simulation, you could tell that we have 5 different sets of simulation. Prior to our simulation, I decided to run 4 different simulations to provide you with a larger sample size. As you can see, by scrolling through the window, you can see all the results of each simulation side by side. In order to better take a look at all the simulation data, I will expand the windows for you. Now, when I click on Test 1, 3 options are provided to you: Update Base, Create New Model, and Plot. I could click Update Base, but I don't want to do that right now. What I'm going to do is create a new model based off Test 1. I'm going to create the model and give it a file name. This file name is going to be tuned IEEE 1. When I click Save and click OK, you can see that a model is now changed to tuned IEEE 1 with the values calculated from Test 1. You will also notice that the reports are no longer made available. In order to get those reports back, we will have to open up our original project. If we go back to Deepeet and take a look at the Deepeet analyzer, you can see that all our simulations are back. You can also update the base from the results, as we are doing now, from Test 2. You can see in the model parameters that the values now change to reflect the results in Test 2. As we go back to the Deepeet analyzer, we will select on Test 1 and plot the deviation points. Again, the Deepeet Result Analyzer is a time-saving software tool used to compare estimated results from multiple sets of simulations involving model parameters. It enables users to select the optimal characteristics and implement the most accurate results into their generator model. This helps users to quickly achieve highly accurate results, integrating precise data and accelerating the design process. Once you have come to a conclusion based off careful analysis, you can easily compile the transfer function and apply it to your specific generator. Once you have applied your model to your system, you are now ready to conduct an accurate transient stability study. ETAP 12.5 supports a new method of short circuit calculation in compliance with the GOST R52735 standards. Built-in intelligence allows the short circuit program to automatically apply all GOST factors and ratios required for high voltage short circuit calculations. By automating the process with multiple calculation and result analysis tools, ETAP 12.5 removes the guesswork from short circuit studies and saves users hundreds of hours of tedious hand calculations. Again, by adding the GOST short circuit standard into ETAP's arsenal of short circuit methodologies, we provide our customers with the ability to conduct studies in regions in which they couldn't previously do so, also allowing their company to expand through the use of the ETAP software. As you can see, I have opened up example IEC in ETAP 12.5. Now what we are going to do is we are going to take a look at the study case. In the study case, you can see that there are now different options in the Standard tab. The Standard tab now consists of the IEC, ANSI, and GOST standard. We will now click OK and move to the studies. What I have done is I've taken a copy of the IEC presentation and turned them to both an IEC and GOST short circuit presentation view. What we will do now is run a study in IEC and also run a study in GOST and compare the results. As you can tell, there are differences in the results. The difference in the results can be contributed to the fact that the GOST standard considers the pre-fault loading conditions while the IEC standard does not. Another enhancement that we've added to ETAP 12.5 is our new library quick pick option. In order to showcase this to you, I'm going to double click on cable 11 and go to the library quick pick in the info page. When I open that up, you can easily tell that the library quick pick menu has drastically changed. What we have done is we have provided the user with the ability to search and sort by clicking on the header. Again, the Library Quick Pick tool is a great tool which allows you to effectively and efficiently get to the specific table in which you are looking for. For instance, if I wanted to sort this table based on the smallest to largest voltage rating, I could easily click on the header and click on Sort Smallest to Largest. In doing so, if I scroll all the way back to the top, I can easily verify that it indeed sorted it to my liking. Also, I could click on the header of the installation type and select the particular installation I am looking for. In this example, I'm only going to select non-magnetic. As you can see, it has sorted it by the voltage rating and also only provided me with the cables that have an installation type of non-magnetic. ETAP has enhanced its platform to be completely localized in 7 languages, plus provide translated output reports in 8 languages. One great application of this would be to use the GAUSS standard in English and then provide the output reports in Russian. The next enhancement I would like to talk about has to do with our scenario wizard. Our scenario wizard now includes the ability to automatically run multiple underground raceway system scenarios with different project files and verify their study results against benchmark reports. We also now provide you direct access within the scenario wizard to our study case editors and our revision and configuration managers. To showcase the changes that we've made in our scenario wizard, let's take a look at example ANSI and go to the scenario wizard itself. When you take a look at the scenario wizard, you can immediately tell that it looks different from the one provided to you in ETAP 12. Not only can you now change between revisions, configurations, and study cases, you can also now easily verify what it is you are running by simply clicking on one of those icons. For instance, if I were to check the study case and see what kind of parameters I have set in there, I can easily click on the suitcase icon and verify what it is that I'm running. We also have the ability, as I mentioned earlier, to do underground thermal analysis in the scenario wizard. This can easily be done by going to Systems, looking at the drop-down menu, and selecting UGS Analysis. What I am going to do now is showcase a UGS analysis through the use of a scenario wizard. What I'm going to do is run one study using the study case CD and show you the results. Now, I'm going to run the same study using a different study case. This time, I will use the study case called Loading. As you can see, the results are drastically different, and I could easily run this through the scenario wizard. What I did in the loading study case was change the loading profile. We have also added some other functionality to the scenario wizard that applies more so to the real-time aspect of ETAP 12.5. This portion will be described in the real-time portion of the ETAP 12.5 webinar series. Through the utilization of ETAP's help desk, I will be showcasing the enhancements that we've made to our library merge process. In order to do so, I will first go to etap.com. Once there, I will click on the Support tab, and in the drop-down menu, I will select the ETAP help desk icon. Once I have selected this icon, it will take me to this page where it will ask me for my username and password. Once we have successfully logged into ETAP's help desk, you can then visit ETAP's FAQ page for the latest ETAP libraries. Now, it may be easier for you to input your own libraries, but before you do that, I would highly recommend checking our FAQ page to make sure to see if we haven't already inputted those libraries for you and save you the work. So what I'm going to do now is take a particular library addition and add it to my existing 12.5 library. Once I have downloaded the link, then open up ETAP 12.5 and continue to make that addition to the 12.5 library. In order to do so, while in a project, I will go to the Library tab and select Library Merge. Once that window opens up, you will have to specify which file will be merged into what file. In this instance, you can see, as denoted by the arrow, that I am taking the top file and merging that into my second file located below the arrow. Again, ETAP's continued growth allows us to devote an entire team to adding libraries. ETAP's engineering libraries include over 3,500 new devices based on user feedback and the latest devices created for the industry. With that, we have reached the conclusion of the ETAP 12.5 offline webinar. We would like to thank you all for taking the time to listen in to the new features and enhancements that we have made to the latest ETAP software. Also, we would love to get your feedback, and we can be reached from sales@etap.com or through our local regional offices near you. Again, we would like to thank you for your time and hope that you have a great day.